Hey guys, told you guys I was going to be gone today, so we are going to do a lesson. We'll be taking a power assignment in a little bit. What you need to do is go ahead and get out your graph paper from yesterday. You should have some graphs left. Okay. If you don't see the sub, there is some extra graph paper, but you're all going to want the one that we had from yesterday. It's the right size. What I want you to do is start off here with these two problems. So once everyone has their graph paper, the sub would pause the video and give the students 4 minutes to complete these two problems. All right. These two problems are going to be on the power assignment. There's about 4 of them like this. This is systems of equations. So one thing I want you to notice is that these are equal signs. Okay? So I am going to put both of my equations on the graph, but I'm looking for an intersection point. Okay? An intersection point. So I'm going to start off, I'm going to graph my top equation. Y-intercept's -7. Slope is -2. That'd be down 2, right 1. Remember we talked about make extra points. I'm going to go the other way. Up 2, left 1. And I need to continue doing that and fill my graph up with points for that line. We'll go ahead and connect it. And one of those points I made should end up being my solution on this problem. Okay, I go to my second one. Y-intercept is 6. Slope is -1, so that's going to be down 1, right 7. That's not getting me any closer to the line, so I need to go the other direction. Up 1, left 7. And they both intersect right there. That particular point is on both lines, so I need to go ahead and name it. Now reminder, it is x comma y. When you name your point, my x coordinate should be -7. My y coordinate should be +7. And that would be my answer for number 1. For number 2, similar deal, you need to graph them both. So y-intercept's 3. Slope is 1/4. Up 1, right 4. And we want to make extra points. Need to go the other way, down and left. And one of those particular points should end up being my solution. I'm doing it right. Go on to my next equation. Y-intercept's -2. The slope is -1. That is -1/1 for that slope. So it'd be down 1, right 1. That's taking me further from any intersection of my red line, so I need to go the other direction. Up 1, left 1. And I'm going to continue doing that, and I find that they intersect right there. Okay, I need to go ahead and connect my points. It's a little off. I apologize, guys. Okay, but they do intersect there. I need to name that point. Please, on your power assignment, do not forget to name that point. My x value for this point is -4. My y value for this point is 2. So you're going to have about 4 of those with equations. The other type you're going to have are these inequalities. Okay? So would please pause the video and give the students 5 minutes to complete these two problems. All right, reminder, with inequalities, we need to pay attention to the type of line, dotted or solid, that we need, and we need to deal with our shading. Okay, so for this first one, I'm going to deal with this top equation. It is in slope-intercept form, so I can go ahead and make assumptions about my shading. This is going to be a solid line because it has the or equal to line. This is a less than symbol, so I'm going to shade down. And I'm going to go ahead and put that on the graph. Y-intercept's -4, slope is -1/4. And we don't have to make extra points, but it does make our graphs more accurate on these inequalities. Okay, so I said solid line, so I want to make sure I'm doing a solid line. And we said shade it down. Now reminder, I want to make sure Okay, I don't color it in darkly because I have two inequalities to put on here. So lightly, I'm just going to draw some lines in that direction. So I know somewhere down there should be where these two intersect. They are different slopes. Okay, so I should end up having an intersection here. The second one, this should be a dotted line because it's missing the or equal to part. Okay, and it is a less than symbol, so this one is also shaded down. Y-intercept is 7. My slope is -3. It'd be down 3, right 1. And I'm going to make extra points so that I'm accurate. Now they do intersect right there. Remember what we had talked about. That's not necessarily a solution because my green line's dotted, signifying it's just a border. Okay, so there's that line. Said we're shading that one down. Okay, so I'm looking for the region where they are both shaded. Okay, where they are both shaded. And that region is just right down here in this bottom corner. So I'm going to color this in dark. Again, like we had talked about, make sure it is obvious which one is your solution. Okay, the second one thing that we should notice right away, these do have same slopes, different y-intercepts, so I'm going to be dealing with parallel lines. That does not automatically mean no solution in an inequality. Okay? But they are going to be parallel. Top one, dotted line, shaded up because that's a greater than sign. I'm going to put it on here. Y-intercept's -7, slope is +2. We'll make sure to make that dotted. Okay, be careful we don't accidentally forget the dotted line. And it's going to be shaded up. So remember, lightly, just going to draw lines in that direction. That way I know that one goes up. Now I need to do my second line. That is solid, equal to part. It's greater than also, and that one is up. So y-intercept's -1. We have a slope of 2 again. And I need to make sure I do my solid line. Okay, see they are parallel, and the green one is also shaded up. So I'm looking for where they're both shaded, and that would be up in this area. And I'm going to color that in darkly. Okay? Now, what I need now, everyone needs to clear their desks with the exception of a writing utensil and a calculator. Remember, you may not use your phones for a calculator. Okay? And if the sub would please pause the video then once everyone's ready to go and pass out the power assignment. It should take approximately 15 to 20 minutes, okay, for you guys to get done with this. Okay? Once we get to about 20 minutes, then we'll have to restart. We will be, make sure you do get a piece of paper for our notes afterwards. So please pause the video right here. All right, everyone should be done with their power assignment. We've got a green flag, so everyone needs to get a piece of paper out for notes. Okay, so please pause the video and make sure that everyone gets out a piece of paper for notes. We're going to introduce today our first algebraic method for solving a system of equations. Okay, now there are some key things that are helpful for us when we do these types of problems. Okay, now we want to know, when is this probably the most useful method? Well, it's most useful when we at least have one of our equations solved. So we're looking for solved equations. It does not necessarily have to be slope-intercept form, but it could be, okay? But it has to be solved. It's either y equals or x equals or what other variable that you're using equals. It's got to be a solved equation. That's what we're looking for, okay? Now, we will see some special cases, and we'll go through those. Remember our special cases, those parallel lines, okay? Same slope, different y-intercept, okay? What you're going to see algebraically is the variables are just going to kind of cancel out and disappear, and you got to look at what's left. So if you don't have the same number on both sides, for instance, if you have 3 equals 3, okay, that's the same answer. 3 equals 3. Okay? That would be infinitely many. Okay? The numbers equal each other. If you have 3 equals 5, well, 3 doesn't equal 5. Okay? The numbers don't equal each other. That means they're parallel lines. Okay? And it would be no solution. We're not going to see a bunch of those, but that is something that we need to be aware of as we're solving. Okay? Now, why do we need another method? Well, let's kind of examine this particular graph. Okay? I went ahead, I already did the graph for this particular system. Y equals 3x minus 5, y equals negative 2/5 x plus 4. Now, just FYI, you don't need to write this part down. Okay? You do not need to write this part down. I just want you to see this. Now, when I look at this, I have different slopes, so I do have a solution for this. Okay? There is a solution. I look at the graph, and they intersect right there. The problem is, I cannot tell just by looking at this graph that precise point. I don't know exactly where that is on the x. I can take a guess, but it's not exact. I don't know exactly where that is on the y because they don't intersect in a perfect spot. Okay? There is still a solution, but I'm going to have to deal in the realm of decimals. Okay? Fractions. So we have to have other methods that can help us out. And that's where substitution is going to help us. If I solve this particular system and use substitution, I'm going to know exactly what the x is, exactly what the y is for that particular point. Okay, so graphing is great. It's a good visual, but it's not always the most accurate in terms of being able to see when we don't use technology. Okay, so these are the way the problem's going to look. Okay, for today, all the problems are going to be just like this. Okay, just for today, as we introduce this. If we notice, first thing, I was asking myself, do I have a solved equation? So make sure you write this down. Okay, please make sure you write this down. Do I have a solved equation? And I look at this and I see y equals and y equals. So technically, I got both equations that are solved right now. Both equations that are solved. Well, in my mind, I need to decide which one is going to be considered my solved equation. They're both solved. Which one's my solved equation? So when they're both solved, I just say, okay, there's my solved equation. Okay? Well, I see it says y equals. So what I'm going to do is I'm going to substitute this in for y in my other equation. So I'm going to take this, what y equals, and I'm going to put it in place of that y. And then I'm going to use the second one to help me build a new equation that I'm going to be able to solve. Okay, so instead of writing y equals 5x minus 7, I'm going to write negative 2x plus 7 in this place. So I go negative 2x plus 7 equals 5x minus 7. And notice now I have an equation with only x's in it. Okay? Now at this point, let's solve it. We've been solving this since the beginning of the year. Let's solve it. Get our x's on one side, numbers on the other. So minus 5x on both sides. That zeroes out. It's positive 7, so minus 7 on both sides. That zeroes out. Combine the terms that are alike. Negative 2x plus negative 5x is negative 7x. Negative 7 plus negative 7 is negative 14. Division. Divide by negative 7 and x equals 2. Now, guys, I got an answer. I got a solution. That's only part of it. All I figured out so far is that the x coordinate, where those intersect on a graph, is my 2. Is x is 2. I still don't know what the y coordinate is. I have to figure out the y coordinate also. So what I do again is I'm going to substitute. I'm going to put 2 in place of x in one of my 2 original equations. It does not matter which one. You got to choose which one you think's easier. I'm going to go ahead and use my top equation here. Okay, so this, I'm going to rewrite it here just one time. Y equals negative 2x plus 7. I'm going to take my solution for my x, 2, and I'm going to plug it in. So I have y y equals negative 2 times 2 plus 7 now. Okay, took the x out, put my answer in. Now I just got to solve this. Negative 2 times 2 is negative 4. Negative 4 plus 7 is 3. There's my y. Okay, so my solution for that particular one would be 2, 3. Let's go on to our next one here. Please make sure you write this down. Now again, we're looking for a solved equation. They're both solved. What's nice when they're both solved, I know I have a solution. Are these going to intersect on a graph? That's what you got to think. We just did graphing, guys. We just did graphing. These have different slopes. If they have different slopes, it has a solution. Okay, so let's go ahead and solve this and figure out what it is. Okay, they're both solved. So I'm going to say, this is my solved equation. Okay, it says y equals, so I'm going to take out my y in my second equation, and I'm going to substitute that in its place. So remember, when I go to write my new equation, I'm using that one as my guide. Okay? I'm no longer writing y equals negative 4x plus 9. Instead of y, I'm going to write 3x minus 12. So 3x minus 12 goes right there. Equals negative 4x plus 9. I have an equation, solve it. Add 4x to both sides. That zeroes out. Add 12 to both sides. That zeroes out. I get 7x equals 21. Finish it. Divide both sides by 7. And x is 3. Again, all I figured out is my x value for my final answer. I still got to plug it back in and figure out what y is. And it does not matter. It don't matter if you use this equation, plug it in for that x, or this equation, plug it in for that x. If you did it right, you'll get the same answer regardless. Okay? So I'm going to use the top equation again. The y equals 3x minus 12. And I'm putting my 3 in for that x. So it's going to be 3 times 3 minus 12. Well, 3 times 3 is 9. And 9 minus 12 is negative 3. So my solution would be 3, negative 3. Okay? I haven't done that in a while. No problem. Number 3. Okay? I want to make sure I show you what those special cases look like when you're doing it algebraically. So when you look at this, we just got done graphing. These things they all connect. Okay? We got to think about what scenario we have here. Are these two going to intersect? So we got to ask yourself, are these two going to intersect? Well, they have the same slope in different starting points. So these are parallel lines. So I know in an equation they're parallel lines. I know my answer. If I'm thinking about it, I know what my final answer is. Okay? They don't intersect. It's no solution. I still have to show my work algebraically. Okay, so let's look at how it ends up as no solution. Again, they're both solved. It says y equals. So I'm going to take the solved one, take my top one. It says y equals, I'm going to put this in place of my y. Okay, so remember, I'm going to then use that one, this one as my guide to write a new equation. So instead of y equals 7x minus 1, I'm going to write 7x plus 2 equals 7x minus 1. And now, I can solve my equation. Watch what happens here. Minus 7x on both sides. What's crazy is both of these zero out. They're both gone. So when I look at these numbers, does 2 equal negative 1? Well, I hope you're not saying yes. 2 does not equal. These are not the same. Okay, so since these don't equal, that's what's telling me to go ahead and write no solution. If I had 2 equals 2, Okay, that's good. That'd be infinitely many. It means we're talking about the exact same line. Okay, they're one over top of each other. Okay, so that's an example of a no solution problem and how it would look, okay, algebraically. What I want you to do here, I want you, so please pause the video. I want you to give the students 2 minutes to do this problem. All right, let's look here. I'm going to consider that my solved one. I'm going to put that in for this y because it says y equals. And we'll start getting into some different ones that don't always say y equals, guys. So right now, keeping it simple, I'm not here. Okay? So just write it. That's my guide. Instead of y equals 2x minus 9, you should write negative 5x plus 19 equals 2x minus 9. And I solve. Minus 2x on both sides. That's 0. Okay? Minus 19 on both sides. That's 0. I'm getting negative 7x equals negative 28. Finish it. Divide both sides by negative 7. The next is 4. So I got that part. I got my x value. Now I got to plug it back in and get my y value. Now when I'm looking at these, you don't always have to use the top one. Okay? You can, but you can use the bottom one. You're going to get the same answer. Okay? I actually prefer the bottom one because it's got smaller numbers in it. So I'm just going to go ahead and use the bottom one here. So we got 4 is my x, so it goes in for x. So 2 times 4 minus 9. 2 times 4 is 8. 8 minus 9 is negative 1. So I get 4 negative 1. Okay? Now, you guys do have a practice worksheet that you're going to be working on. I also put this worksheet on Google Classroom, so you have a copy, a digital copy, but I went ahead and made a paper copy for you guys. These are your answers. Need you guys to go ahead and get started on that worksheet once you get it from the sub. Okay, and so please pass that worksheet out to them. Go ahead and leave this up there, pause, so that they can see the solutions as they're going through. Okay, and you guys have a wonderful weekend. We'll see you on Monday, and we will continue on with substitution. All right, bye.